Hello my friends, today a little project for you. If you want to manufacture the cheapest single 18650 lithium polymer battery charger, here we are. This is it. This is how it looks like. You can obviously somehow put it all together, but in sake of explanation how it looks and works, I just keep it like that. So what we need to have, or what we need to source. First of all, we need to source our battery holder, because we need to charge 18650 battery, so we have to put it into something. If you can also charge 18500 or 18350, which is just smaller factors of this, the same battery, or any other single cell lithium polymer battery, which are running at 4.2 charging current 4.2 and running voltage 3.7 volts. Maybe this is not the first step. First of all, you have to source this little charging unit, which actually can be bought super cheap on eBay and Alibaba and other sites like that. You can get the link below where to source them, and you can buy them for dirt cheap as well. So all this little contraption gonna cost you maximum $2. And if you source somewhere super cheap Chinese batteries, maybe even altogether all this gonna cost you like $3-4 in total. So obviously the brain of the operation has this little unit. So this allows you to connect your micro USB over here, do some magic over here, and put some electricity into this battery, charge it, and if you want to pull it and use in your project, or you can charge it and then use in your project via those pins. So this unit have battery charging pins and also some output pins, which you can use power some by something else. Obviously this is gonna be at the battery voltage essentially. So when it's charged, it's gonna be from 3.7 to 4.2 volts. If it's gonna drop lower than that, the protection will kick in. So because this unit has a little bit more brains. How did I build it? Well, this is really self-explanatory. Take this battery holder, connect it to appropriately red to B+, blue to B-. Obviously have to observe your polarity in the battery you inserted. Then connect this load if you need it. If you don't even bother soldering this stuff. So having those two connected, then just grab your micro USB cord, just like this, plug it in, that's it, it's charging, that's it. This battery is charging now, which is indicated by this. When it's finished charging, it stop the light, it's gonna turn the blue light. So that's it, that's the easiest you can go. Few dollars and you are good to go. So guys, this is pretty much it. You have the cheapest charger you can get. If you want to know more about how this all operates, please stick around. But if you want to just rush and build it yourself and start playing with it, stop here, and thank you for watching. Alright, for those people who want to stick around, let's look into some theory here. Okay, theory is here. Okay, I'm gonna put this unit aside, and here is the schematic of the little battery charger we just looked at. As you see, it has 3 chips. Let's take a look at each of them. Here is the one, which is battery controller. Here is protection things. And there is input over here, and battery contacts over here where you connect the battery, and load, which you connect your load if you need to, or if you just charge battery, you just connect battery over here. So let's talk about this charging controller chip. This charging controller chip is TP4056, and there are many clones of this guy exist, and it's very popular in and very instrumental of actually charging your lithium battery properly. So what's so special about it? It's really designed to charge a single cell lithium polymer battery, because charging voltage is 4.2 volt, and it has programmable currents, and input voltage is 4 to 8 volt. 4 volt, I'm not sure how it's gonna charge actually properly if at 4 volt, because it doesn't have any boosting. So that's something I don't know. But nominal voltage of operation is 5 volt, tops is 8 volt. So this is the schematic. It also has some indication pins which connected to those LEDs in this particular case, and you can see the charge and discharge and standby indication. So standby essentially means a charge which is going to be blue in this case, and this in this particular implementation, and or red. So on the other hand, we have also another side. We have also programming pin. This programming pin allow you to change by changing this resistor, the table which is in documentation of the resistors and currents. Change your charging current. So it can be from 180 milliamps to 1 amp. So 1 amp is the top. Very maximum current this thing can push is 1.2 amp, but this is already pushing it. So this is maximum. So 1 amp charging current is good. Temp is the pin which allow you to connect your NTC thermistor, but in this particular case they don't do it, as obviously it's to save some cost. So in order, if you want to do it yourself, you have to break this from the ground, wire your thermistor over here, or thermoresistor, and NTC, and put it somewhere close to the battery over here. So here's your battery gonna be here somewhere, LiPo battery, and thermistor should be placed right beside it. Let me see. Okay, so it won't be grounded. So this is supposed to come. You understand me what I'm saying? Like this is supposed to be in the ground, and this is supposed to be, because this is the ground, and this is supposed to be connected to this over here, this side, to over here. Anyway, so in this case you will be able to monitor the temperature of your battery and shut the charging down when it's too hot, which is very important, because sometimes those busters can go hot and explode sometimes. Okay, what else we have? Obviously the battery is the charging contact, so it goes to the battery. In this case, out and batteries are connected together because they are this side didn't have any logic. But if you look over here, and the negative of the battery has a whole bunch of things sitting on it. So essentially this is protection circuit. This guy is doing just charging logic. This is protection, two protection chips. So here we are. So this DW01A is this little 6-pin jobby, and this dude, as you see, this is two MOSFETs. This it's called 8205A is this 8-pin jobby, but like because for current carrying capabilities those are together. And you can take a look in this a little bit closer, because I printed some schematic just for those little dudes. So let's take a look first at DW0A. So this dude is overcharging, over discharging, over current, and over short circuit protection for your battery. This is very important chip to have when you're charging your little polymer batteries and when you're discharging them as well. Because if something goes wrong, lithium polymer battery have tendency to go violent, and to prevent this you need some solution like that. So as you see, it has CS, this current sense contact, which are gonna monitor the current and obviously drop out or shut down the charging when there is a over current and short. This monitored over here. There is also over discharge and overcharge. So over discharge, when the battery voltage goes battery voltage go low. So in this particular unit has 2.4 volt for over discharge, and when it drops that quickly to this voltage, it stops charging and will not continue charging before battery bounce back to 3 volt, or never if battery is scrapped out. Overcharge will trigger when there is from 3 volts and will return back to charging when there is a 4.1 volt reached again. So battery has to drop back to 4.1 volt. Over here you see two MOSFETs. These particular diodes are required in order to actually turn on and off those things. So essentially to break down this line which goes to battery minus. So, and this work will be performed by ML, oops, you don't see that, ML 0205. Sorry, 8205. There are many of different clones of this particular one. Different companies produce them, as well as they add two other components over here. So this is the typical how it looks like. It's essentially two MOSFETs. Drains are connected, and this is just required to. It can carry some current, and it's required to be used in conjunction with this particular DW01. Obviously you can use two separate MOSFETs, no big deal, but this is just form saving factor. And here, by the way, this is 6-pin Joby, and the one I have over here is 8, but two middle ones are connected together, so this is essentially the same. Here's some information. All those specs, all those sheets I would include, those PDFs I will include with this video for you to examine, and obviously they are much bigger than just one page. So here we are. So we're back to our square one over here. So we already discussed this diode, So the same as you see, our discharge, current sense, and overcharge contacts are over here. So, and they connected to appropriate places to this MOSFET. All right, so what else we have? That's pretty much it. That's output capacitor. But everything else is just some boilerplate components to actually have this thing running. Here is the older design of the similar unit, and it has mini USB, as you see. This is the older unit, and the reason I'm not using this one because it doesn't have protection, unless some of the 18650s have, or LiPo batteries have protection built in them. In this case you can use it, or you can buy a little separate, little mini teeny tiny kind of protection circuit and insert or solder it to your battery in a way that it's gonna protect it for charging, overcharging, over discharging. It is very important to understand how those little boards work, and if they work at all before actually using a new application, because this is very important that those units actually perform how they're supposed to be, because if there is a malfunction over here, a malfunction over here, you can end up with kaboom over here. But before you actually use anything like this in your application, better test them well. And this one, I think, sorry, no, this one is actually faulty. Yes, you see, bad, because I tested all of them and this end up to be not working, and probably there is a short circuit somewhere in the PCB, and after like 5 minutes this chip overheated and exploded. Not exploded, it burned. So yeah, I didn't dig too much, but it's there is a problem here. So I may just suck this chip out and put it here, because this is useless, this is useful. Actually, if there is a short, nah, never mind then. So this one and this one obviously is operational, so I can continue playing with this one. So here we are, guys. This is the little project for you if you want to build something on your own, and a little bit of theory behind how this stuff works and what can you do about it. With this diode, what you can do, you can add your thermistor to check your battery temperature and make sure it's all good and dandy. And also you can change this programming resistor, which is this little diode over here, R3, in order to tweak your current if you want a higher or lower current. Like a higher current is fast charge, we're gonna charge faster, but if it's crappy battery, it may degrade faster and obviously gonna heat more. And lower current is better in terms of like it not gonna stress battery as much, especially if it's crappy battery, but it's gonna charge longer, and on the positive side the temperature will be not as high. This is pretty much it, guys. Stay safe with your lithium battery and have a nice day. See you next time.